Welcome to section 9.1.2, where we'll be talking about series and sequence of partial sums. So we're going to consider a sequence just like in the last video. That's just a list of numbers. In this section, we want to add up all of the terms of this sequence. So that means we want to add up A1 plus A2 plus A3 plus A4, and it never ends. It's an infinite list, and so you keep going. To make sense of this infinite sum, we'll look at partial sums Sn that add up only a finite number of terms. All right, so let's see what we have. I'm going to start with a sequence. I'm going to define series and partial sums. The series of this sequence is the expression. So we're going to use the sigma notation that we had in chapter 4. So from 1 to infinity of an. So same notation as in chapter 4, it's just that instead of finishing at some point, we just say you keep going to infinity. The nth partial sums of an is Sn. We add up a1 plus a2, and now we do stop. We stop when you reach n, so up to an. All right, so we start with a list of numbers, and then we start adding a certain number of them. So for example, S1 would mean you just add up A1. S2, you add up A1 and A2. S3, you add up A1, A2, and A3. S4 would be this, sum. And so we get a second list of numbers, a second sequence, and the sequence of partial sum is exactly that. So Sn, n equals 1 to infinity. All right, so we start with one list, we build a second one, of numbers. Let me show you that in an example just to make sure everybody's on board before we start talking about limits. So let's say I want to evaluate the sum of this series. Sum from n equals 1 to infinity of 1/2 to the n. I want to evaluate the first 4 partial sums of this. All right, so S1, we add up to 1, so we add up the first term. That's 1/2 to the 1. That's 1/2. S2, we add up the first 2 terms. And so we get 1/2 plus 1/2 squared. And so we get 1/2 plus 1/4. We get 3/4. All right, let's do 2 more. S3, we add up A1, A2, and A3. So that's 1/2 plus 1/4. For n equals 3, you get 1/8. And so you end up with 7/8. And S4 would be A1 plus A2 plus A3 plus A4. So 1/2 plus 1/4 plus 1/8 plus 1/16. And so you would get 15 on 16. All right, so the sequence of partial sum would start with 1/2, then you'd have 3/4, you'd have 7/8, and you have 15/16. And it keeps going forever. All right, so now we want to figure out what the full complete sum is. And so I want to find an expression for the partial sum Sn. All right, so I'm going to draw a picture here. I'm going to draw a square. That's 1 by 1. All right, so the first term is 1/2. So first term, 1/2, I'm missing 1/2 for that. To get the full area. Now, if I do S2, actually let me put that underneath so I have room for S2. If I do S2, I'm going to take 1/2 plus 1/4. And so I'm missing 1/4. So S2 is 1 minus 1/4. So at every step, you take out an extra term that's half of what you had before. So here we add an extra 8, so we're still missing 1/8. And so in general, from this picture, we could see that Sn is 1 minus, and there's one term missing, which is 1 over 2 to the n. All right, so that's what the partial sum means. So you add up a bunch of terms. The number of terms you add up keep increasing, and you try to figure out a pattern. All right, so let's see how this relates to the full series. So definition 9.1.3, convergence of a series. Let AN be a series with partial sum Sn. Assume that the sequence of partial sum is convergent with the limit goes to S. All right, so this is the one we care about, those sum of a finite number of terms from 1 to n. Then if the series sequence of partial sum gives you a limit, then the series is then called convergent, and the sum of the series is that limit S. If the sequence of partial sum diverges, then the series is called divergent. So a series is really a limit, just like an improper integral was really a limit. It's a limit, and to figure out what the limit is, you first need to figure out what the partial sums are and then apply a limit to that sequence. All right, so this is, I'll write it better in a second. Determine whether the series converges, and if it does, find its sum. So that's, I didn't say so here, but it's continued from this example. All right, so it's still the same thing here. We had a formula, so from B, we know that Sn is 1 minus 1 over 2 to the n, and so we look at this limit. And that will give you 1 minus 1, 2 to the infinity. This goes to 0, and so I get 1. All right, so if you get a real number when you look at this limit, then the series converges. The series, what was the series? Sum n equals 1 to infinity of 1 to the n converges, and its sum is 1. All right, so if you can find an expression for partial sums, then all you have to do is apply a limit to it.